Okay, so here's something that's kind of different. There's going to be something called an extraneous root. Now, sounds like a really complicated word, doesn't it? Just remember this. This just means extra root. In other words, a root that does not work. What do I mean by that? Well, wait, you'll see. And if you have extraneous roots and you don't know if you have them or not, what you got to do is you got to verify first. Okay, so wow, is this ever going to be cool? We're going to do this algebraically in this particular podcast, and in the next podcast, we're going to do this on the calculator. So there's two different ways of doing this. And I prefer, well, you know, I can't say I prefer one over the other because they both have their advantages. Okay, I'll shut up. Let's go to work. First things first, there's 3x minus 5. Let's find the restriction. Bring the 5 over. This is 3x, blah, 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 blah. Divide by 3, divide by 3. X has got to be greater than or equal to 5/3. Good. Okay, so there's our restriction. We got that out of the way. Now, let's start solving. Same as before, bring the 5 over. Okay, that's gone, leaving you the square root of 3x minus 5 equals to x minus 5. You know and I know then what we have to do is we have to square both sides. Okay, so we're going to square this side, boom, and we're going to square this side. So don't forget, that ends up having to be FOILed. This plain old is 3x minus 5. This guy has to be FOILed, giving you x minus 5, x minus 5. Okay, great. So we've got 3x minus 5 on this side. First, x squared, inner, or outer, inner, and finally last. Okay, so keep on going here. All right, let's add these guys together, combine like terms. So 3x minus 5, we're still good. This is x squared minus 10x plus 25. Let's combine everything by bringing it all over to one side. So subtract the 3x from this. Okay, beautiful. Giving us, check this out, 3x's cancel, giving you x squared minus 13x. Okay, and then finally, we have to make sure that we get rid of this 5 as well. So we're going to add 5 to both sides. Add 5 to both sides. So this is going to be plus 30. This is all going to equal to 0. Well, look at that. This is just the last unit. This is a quadratic that we have equaling to 0, which means, guess what? You got it. BSA. You got it. So we've got a factor now. This is 30 minus 13, easy as pie. Well, actually, ever try to make a pie? Not easy. All right, so minus 10 and minus 3. Here we go. So this is x minus 10, x minus 3 equals to 0. So look how easy this is. We're getting some really nice solutions here. We're getting an x equaling to 10 and an x equaling to 3. Check the restriction. If you remember, the restriction up here was x has to be greater than or equal to 5 over 3. So if you think about it, x has to be greater than or equal to 5 over 3, which is basically x has to be greater or equal to 1 and 0.6 repeating. Okay, well, guess what? Both of them are bigger than 1.6, yeah. So one of them, I'm going to tell you right now, doesn't work. Which one? Go back to the original equation. Here's the original equation way up here. 5 plus the square root of 3x minus 5 plus, equals to x. So I'm going to grab this thing and I'm just going to move it right down to where we were. Okay, so a little bit down here, a little bit down here. Whoops, see, a little bit down here. Here it comes. Here it comes. Down here. Still more. Still more. Finally, we're there. So here's what we got to do with this now. Going back to the original question now, let's see by substituting these values in whether or not we get the right answer and whether or not this actually works. So, okay, let's try with x equals 10 first. X equals 10 says, okay, I've got 5 plus the square root of 3. Now, don't forget, x equals 10, so you can put 10 in there, right? Minus 5 equals to 10. That's just by substituting the value of 10 into here and into here. Okay, with me? Perfect. So 5 plus the square root. 3 times 10 is 30. Minus 5, okay, has to equal to 10. All right, let's keep on going here. Here we go. 30 minus 5 is 25. So plus 5 plus the square root of 25, right? Okay, has to equal to 10. So square root of 25 is 5. And lo and behold, oh my goodness, look at that. 5 plus 5, 10 equals to 10. So that works. So we know that our x equals to, what was the number that we substituted in? Oh, x equals to 10. We know that x equals to 10 is a good answer. Ah, perfect. Awesome. Look at that. Gorgeous. Now, let's try the other one to see what happens. Remember what the other answer was? No, I don't. Oh, yeah, it was 3. Okay, so let's try the x equals to 3. Here we go. 5 plus the square root of 3 times 3 minus 5 has to equal to 3. Okay, 3 times 3 is 9, minus 5, right? Plus the 5 here. 9 minus 5 is 4. Okay, it's 4. I know the square root of 4 is 2. That ends up being 7. Well, wait a second. That all has to equal to what? That has to equal to 3. Wait a second. That doesn't work. 7 doesn't equal to 3. So guess what? This x equals to 3 is a garbage root. It doesn't work. In other words, oh my goodness, I hate to say this, algebra lied to you. And when you solve this, algebra lied, okay? So guess what? You proved that by verifying the solution. So this is actually the extra root, or what we call the extraneous root. Okay, that's the extraneous one. And that's the reason why you always have to prove this by solving. The very next podcast, I'm going to do the exact same thing, but we're going to use a calculator, and you're going to see how one works over the other.